Hello everyone. Today we are going to solve the problem swap and maximize. So it is a difficult to easy question. So given an array ARR of positive elements, so we need to consider array as circular array, meaning element after the last element is the first element. So our task is to find the maximum sum of absolute differences between consecutive elements. With shuffling an array elements is allowed. So shuffling the array elements and make A1 and An such that the order that A1 minus A2 plus A2 minus A3 and go on is maximized. So this is a particular question we are talking about, and also the other time and space complexities they expected. So now we will note down the first sample input and let's see how we need to solve this program. So the first sample input is array. The array is 4 2 4 2 1 8. So the array is 4 2 1 8. So now let's see. This is the array given. So our first step is, so let's discuss. So the difference between two numbers will be minimized when there are two different numbers, like one is the least possible value and another is the highest possible value. So like 1 and 8, then the difference will be 7. Rather than 7 and 8, the difference is 1. So that means the difference between the largest value and the shortest value will always result in the least difference, leading to the maximum value by adding. So for that purpose, to easily find the minimum and maximum values consecutively, we will sort the array. So after sorting the array will become 1 2 4 8. So after this, there is a simple formula for this question, which is, so to get the maximum sum of absolute differences, we will have the formula that is 2 into maximum 2 into sum of large half minus sum of small half. So this is the formula. So if you solve this program according to this formula, then for the particular question above, so we initialize the sum with, so sum is 0, and next we will keep on adding. So we will only continue up to that where the I will be 0 to n by 2 only, because we need to only process the half of the array only. So for I is equals to 0, so for I is equals to 0, sum is equals to, it was already 0, so 0 plus what is the largest element, it is 8 from the backward, minus what is smallest, it is 1, so the sum is equals to 7. So next, for I is equals to 1, so n is 4, 4 by 2 is 2 only, so up to 1 only the last iteration will be continued. So sum 7 plus 4 minus 2. So 7 plus 4 minus 2 is equals to 9. So at last the sum value will be 2 into sum, which is 18. So therefore the output is 18. So if you see in the program 4218, the output is 18. So it is very easy formula. 2 into sum of large halves minus sum of small halves. So simply we will apply the logic here. Sorting of array and initialize sum value equal to 0. So for int I is equals to 0 to I less than length by 2 I plus plus sum plus equal to, so we will remove the smallest value, which is array of I, and add the largest value, which is array of, let us take the length of array as n is equals to array of length. So here we can use the n value and also n minus I minus 1. So we will get the opposite value of the I value, which is the last value. So at last return the sum. So we set 2 into sum. So we can see the sample input is passed and the evident test case so we can see they are passed. So now if you analyze the time and space complexities, this will take n log n and big O of 1 simple variable, big O of 1 n. So at last, so time will be the maximum value, which is n log n. Space will be 1 because we didn't use any dynamic space. So if you compare also, they are matching. So this is the best possible way to solve this program, and also it is easy to understand the simple formula, which is 2 into sum of large half minus sum of small half. So kindly go and practice the program. The program link is given in the description. Thank you for watching. Subscribe for more videos.